In this video, we are going to discuss about continuous probability distribution. Now we look into one more example. If the probability density function of a random variable is given by f of x equal to k of 1 minus x square between limits 0 less than x less than 1 and is 0 elsewhere. We have to find the value of k and also the probability values between 0.1, 0.2 and greater than 0.5. So first I'll find out the value of k. We know that integral from minus infinity to infinity f of x dx is equal to 1. Since given f of x is probability density function. Now using this we'll find the value of k. So what we have? Minus infinity, the function is defined between 0 and 1, remaining it is 0. So I'll divide this interval from minus infinity to 0, f of x dx plus 0 to 1, f of x dx plus 1 to infinity, f of x dx is equal to 1. So now between minus infinity and 0 and 1 to infinity, the function value is 0. So if I write down here 0 plus, and the function is k of 1 minus x square dx plus 0 is equal to 1. Now I'll integrate this part. So k x minus integral of x square is x cube by 3 between 0 and 1 is equal to 1. Now substituting the limits, what we have? K 1 minus 1 by 3 minus 0 is equal to 1. So k 3 minus 1 is 2 by 3 is equal to 1. This implies k value is equal to 3 by 2. So k is equal to 3 by 2. So first we found the value of k. Now we have to find the probability value between 0.1, 0.2, also greater than 0.5. Now we'll write down the function again. Since k value is 3 by 2, we got it. So I'll redefine the function as 3 by 2 of 1 minus x square between 0 and 1 and 0 elsewhere. So he asked you to find the probability value between 0.1 less than x less than 0.2. So we'll find probability of 0.1 less than x less than 0.2, and since 0.1 and 0.2 will lie in the given interval, will be defined between 0 and 1, we can write this as integral from 0 to 1, 0.1 to 0.2 f of x dx. That is, now I'll write f of x. So 3 by 2 integral from 0.1 to 0.2 1 minus x square dx. So this is equal to, I'll integrate. So 3 by 2 integrating, we have x minus x cube by 3 between 0.1 0.2. So this is equal to 3 by 2, substitute the upper limit 0.2 minus 0.2 whole cube by 3. Now substitute the lower limit. So minus 0.1 plus 0.1 whole cube by 3. On simplifying, this value will be equal to 0.2965. So, probability value of the given function between 0.1 and 0.2 is 0.2965. Now, we will find out the probability value greater than Now, we will find the probability value greater than 0.5. And we know that the function is defined as f of x is equal to 3 by 2 of 1 minus x square for 0 less than x less than 1. So, now we have to find out from 0.5 to infinity. So, if you see the given interval 0 and 1, then the value of x will lie between 0.5 to 1 and the remaining value will be infinity. So, this will be equal to 0.5, upper limit will be infinity, f of x dx. So, this will give us 0.5 to 1 f of x dx plus 1 to infinity f of x dx. So, 1 to infinity value is 0, we will integrate only this part. So, this is equal to 3 by 2 integral from 0.5 to 1 and the function is 1 minus x square dx plus, and this value is 0. So, integrating we have 3 by 2 x minus x cube by 3 between 0.5 to 1. Now, we will substitute the upper limit and lower limit. Now, this is equal to substituting the upper and lower limits 3 by 2. Substitute the upper limit first 1 minus 1 by 3, then substitute the lower limit minus 0.5 plus 0.5 whole cube by 3, right. And on simplifying this value, the probability for x greater than 0.5 is equal to 0.3125. So, probability value of x greater than 0.5 is 0.3125. Now, we will look at another example. Now, in this example, a continuous random variable distribution function is given, that is capital F of x cumulative distribution function is given. We have to determine f of x value, that is probability density function. We have to find out the k value and then mean. So, first we will find out probability density function. So, we know that f of x is given by integral from minus infinity to x f of x dx, and from here f of x is given by d by dx of cumulative function, that is capital F of x. So, this will be equal to, on differentiating we will have this is 0. So, for x less than or equal to 1, and here we have k into x minus 1 to the power of 4. So, differentiating what we have 4k x minus 1 whole cube in the interval 1 less than x less than or equal to 3, and differential of 1 is 0 for x greater than 3. So, we have f of x as 0 bit for x less than or equal to 1, 4k into x minus 1 whole cube between 1 and 3, and 0 for x greater than 3. Now, we will find out this k value. So, what we know again, since he has given that the given f of x is a probability density function, we know that since f of x is probability density function, integral from minus infinity to infinity, f of x dx will be equal to 1, right. Now, I will find out this k value. we see that the function is defined between 1 to 3. So, we will write this as minus infinity to upper limit should be 1 f of x dx plus 1 to 3 f of x dx plus 3 to infinity f of x dx should be equal to 1. And we say that between minus infinity and 1 the value is 0 and greater than 3 also the value is 0. So, this can be written as 0 plus from 1 to 3 the function is defined. So, 4k integral from 1 to 3 x minus 1 whole cube dx plus 0 is equal to 1. Now, I will simplify here. So, integrating we have 4k and integral of x minus 1 whole cube is x minus 1 whole to the power of 4 by 4 and differential of x is 1 and this is 0. So, between limits 1 to 3 equal to 1. Now, simplifying this, substitute the upper limits and lower limit. So, we have k of, first substituting the upper limit 3 minus 1 to the power of 4. So, we have 3 minus 1 to the power of 4 and substituting the lower limit minus 1 minus 1 to the power of 4 is equal to 1. So, this is k. Here we will have 2 to the power of 4 minus 0 is equal to 1 and we know 2 power 4 is 16. So, 16k is equal to 1, that is k is equal to 1 by 16. Now, we can redefine the probability density function, that is here we will substitute k value as 1 by 16. So, what will be the function? Now, f of x will be now we will find out mean for this function. So, mean is given by integral of x f of x dx between limits minus infinity to infinity. Again we will define this function from minus infinity to 1 x f of x dx plus 1 to 3 limits as 1 to 3 x f of x dx plus 3 to infinity x f of x dx. And we know between minus infinity to 1 and 3 to infinity the value is 0. So, this is equal to 0 plus, now I will define the function f of x which is in interval 1 and 3. So, 1 by 4 integral from 1 to 3, here it is given as x minus 1 whole cube and this x is there. So, x into x minus 1 whole cube dx plus 0. Now, we will integrate this. Before that we will simplify this part. So, we can write this as (1 by 4) limits from 1 to 3 x and then integrating expanding x minus 1 whole cube, we have it as what? A cube minus 3ab square. So, minus 3x square plus 3x minus 1 dx. So, this is equal to 1 by 4 of limits from 1 to 3, take x inside. So, x power 4 minus 3x cube plus 3x square minus x dx. Integrating, 1 by 4 x to the power of 5 by 5 minus 3 integral of x cube is x power 4 by 4 plus 3 x cube by 3 and integral of x is x square by 2 between limits 1 and 3. On substituting the upper limit and lower upper limit 3 and lower limit 1, we get the value as 13 by 5. So, mean value is given by 13 by 5. Thank you.